Good morning. In this video, we are going to discuss about perpendicular axis theorem, a very important theorem. There are three axes in a Cartesian coordinate x, y, and z axis. Generally, the object is placed in xy coordinate and then we do our work. Here also, if we take this case, here the object is placed in a x and y coordinates. So here the object is placed and the rotation of this object with respect to x and with respect to y are to be studied. That makes us to learn the moment of inertia with respect to x axis and y axis. Okay, so but in some cases, okay, it is very important to learn the moment of inertia with respect to perpendicular axis. Perpendicular axis means perpendicular to this paper, perpendicular to this paper. Okay, in most of the engineering applications have this rotation. If you take the ceiling fan in our home, you know that here the rotation takes place with respect to perpendicular axis. And one another example is if you take the rotation of our wheel in a two-wheeler or four-wheeler, where the rotation takes place with respect to perpendicular axis. So the rotation with respect to perpendicular axis means we have to find the inertia with respect to perpendicular axis. So for that purpose, this theorem helps us. Now let us see the definition of perpendicular axis theorem. It states that the moment of inertia about a perpendicular axis to the plane is equal to the sum of the moment of inertia about two mutually perpendicular axes lying in the same plane. Okay, so this is the definition. Now it is simplified as IZ, which is the moment of inertia with respect to z axis. A perpendicular axis is equal to the summation of moment of inertia of two axes x and y. These two axes are lying in the same plane. Okay, now the formula is Ix, moment of inertia about Ox axis is integration of y square dm. If you take this diagram, here the mass dm is located. Now this is the distance between dm and x axis. Okay, so here is the y. So integration of y square dm will give the moment of inertia with respect to x axis. Similarly, x is the distance between y axis and dm. Now integration of x square dm will give the moment of inertia with respect to y axis. Now we have to find the Iz, that is moment of inertia with respect to OZ axis, where OZ is perpendicular to this paper, okay. And so as per the definition, this is the answer. Iz is equal to Ix plus Iy. But let us see the proof now. Now consider R, which is the distance between the Z axis and the small mass dm. Okay. Now moment of inertia with respect to this Z axis is equal to integration of r square dm, because r is the perpendicular distance between Z axis and dm. Okay, like this only, where y is the perpendicular distance between x and dm. Similarly, x is the perpendicular distance between y and dm. In the similar manner, here this is the formula Iz equal to integration of r square dm. Let me take this as the equation number 1. Now let us take this triangle OAB and I am going to draw separately. So here is the diagram OAB. Now in the triangle, R is the hypotenuse and x is the x and y are the other two sides. Now we know that as per Pythagoras theorem, r square equal to x square plus y square. Now I am going to substitute into the first equation. It is Iz equal to integration of r square dm. In the place of r square, I am going to substitute this one, x square plus y square. So the equation will become something like this. Now I'm going to separate or split this equation into two, integration of x square dm plus integration of y square dm. Now you know one thing, that integration of x square dm is nothing but the moment of inertia with respect to y axis. Similarly, this is moment of inertia with respect to x axis. So this is what here it is written. So finally it is that Iz equal to Ix plus Iy. So this is the perpendicular axis theorem. It is now proved.